What we have right here is we have our review for our Algebra 2 test. This is going to be your next test, lessons 1 through 60. I'm going to try to cover this, as much of this in as detailed as I can so you're ready for your test. Our first question comes up here. It's from lesson 34, graphing linear equations. What we see right off the bat is that we have a vertical line, and vertical lines are represented as x equals because the x value doesn't change and there's no slope. So what you're simply looking at is what is the x value. As we look at here, it goes over -1, -2, and it's actually -3. So we get this, and if you're looking for a question like this, what kind of work do I need to show? I'm going to say that, x equals -3 because it's a vertical line. Vertical lines are x equals. So a simple sentence there will work with our x equals on that. Question number 2. Which of the following is a factor of x cubed plus 6x squared minus 16x minus 69? Comes from lesson 38. So if I want to factor this, probably what I'm going to do is I'm going to factor it by grouping. On this section here, I can take out an x squared, which is going to leave me with x plus 6. On our other one, we're looking for what we can take out of 16x minus 96. And if we take out 16, so we should get -16. Okay, if we take a 16 out of that, and -96 divided by -16 comes out as +6. So if we factor that -16 back in, we would get what we started with, which means we're going to bring these guys down. So I've got x squared minus 16 as a factor, and I've got x plus 6 as a factor. Now you'll notice that none of those answers are part of the solution set. And so I want to actually look at this guy, and can I break that down any further? And because I have an x squared minus a perfect square, I can, where I'm going to get x minus 4, x plus 4, and again I can bring down my x plus 6. So now I can look, those are my 3 factors, and we see that x minus 4 is the factor that I want to use. So that's exactly the work that I would show. You can circle the x minus 4 that's in that. Okay, so you want to look for places where it can break down a little bit further. Question number 3. Okay, question number 3 comes from lesson 43, solving systems of linear inequalities. Which ordered pair is a solution to this system of inequalities? All right. All right, this question is a little easier than it appears. We're looking for, and you could look down through here, because it says which ordered pair, we're actually not just solving, but we're going to be plugging in. So what I want you to see is that it says in our first one, x has to be less than 5, which is going to get rid of a. So I could say, hey, 5 is not less than 5. Okay, so I'm going to get rid of that one. Now, b, it tells me that I have -5 for my x, which works. -5 is less than 5, and so let's test the rest of it. Well, as I plug it in here, that's going to give me 5 plus 4 times 2 is greater than or equal to 17. Well, 4 times 2 is 8, 5 plus 8 is 13, which is not greater than or equal to 17. So I can eliminate B as an answer. Now, before I can say none correct, I really do need to check the rest of them. 4 is less than 5. So let's check -4 plus 4 times 0. Is that greater than or equal to 17? Well, 4 times 0 is 0, and -4 is certainly not greater than 17 on its own. So D is not my answer. Finally, we want to take E and plug our stuff in here. 3 is less than 5. That works. And then we have -3 plus 4 times 5. Okay, is that greater than 17? Well, 4 times 5 is 20. -3 plus 20 is 17. And that is greater than or specifically equal to 17. So E is my answer there. So at the very least, need to see how you've plugged 3 and 5 into that and show me that it works. Okay. Question number 4: which is the best estimate of correlation coefficient of the data in the graph? All right, this is where we go back to looking at the data. Is it close to being a line or is it scattered? And remember that as it gets closer to being a line, it either gets close to being -1 or +1. As it gets further away from being a straight line, it approaches more like 0.1 or -0.1. And so as we look at this, I'm going to say that it is scattered. And it largely is negative from left to right. Okay? And because it's scattered, we're looking for something along the lines of 0.1. And because it's going relatively down from left to right, we're going to go with -0.1. Okay? That's one where a simple answer, a simple couple of words or a sentence, I prefer a sentence in there where we're saying the data is scattered and relatively negative, we're going to use -0.1. Okay, we've seen some examples of that. I'll tell you where that comes from. That comes from lesson 45, finding the line of best fit. Now we get into 5, find the zeros of the quadratic equation. And notice that both of these are perfect squares. So we can do 7x minus 6 times 7x plus 6. Now, because it wanted us to find the zeros, we're going to set both of these equal to 0. So 7x minus 6 equals 0. Add 6 and divide by 7. So x equals 6/7. Same thing over here. 7x plus 6 equals 0. Subtract 6, divide by 7. X equals -6/7. So we could say x equals positive or -6/7. Okay, again, that's the work that we expect to see on a question like that. Okay, question number 6. Ask me to divide. Now, the biggest thing to remember is that we're dividing two fractions is that I can't really divide by a fraction, but I can multiply by the reciprocal. So if I wanted to rewrite this, and I should write 5x to the 9th over 9x to the 8th y times 9y to the 8th over 25, and then multiply across. 5 times 9 is 45. X to the 9th, y to the 8th. And across the bottom, I've got 9 times 25, okay, which is 225. X to the 8th, y. Now we can go about eliminating and bringing this down. Well, 45 divided by 225, both those numbers are divisible by 5. 45 divided by 5 is 9. 225 divided by 5 is 45. Both those numbers are divisible by 9. So my number will cancel out, and I should get 45 on the bottom alone. If I bring that x to the 8th up, it becomes x to the 9th times x to the -8th. I would add those two together, and I would be left with just x. If I bring my y up, that becomes -1. Y to the 8th times y to the -1 is y to the 7th. So if I look at the answer here, we should get x, y to the 7th over, okay, they're getting to the 5th. Maybe I did that wrong, because I can divide 225 by 45, and yeah, I'm left with just 5. So I'm actually dividing by 45 on both those numbers, giving me 1/5. Okay? I won't count it wrong if you put a 1 there, although it is not necessary. Okay, number 7. Graph y equals x plus 2. Describe the transformation of the graph of y equals x to get the graph of y equals x plus 2. Let's see. So I'll just, if I can do this here, let's see. Let's actually pull up another page here and clear some stuff out. Okay. We have y equals x plus 2. So we're noticing that our slope is 1 and our y-intercept is 2. Okay, so as we kind of look across here, okay, we're at 2 and we're going up 1 over 1. So something like this, okay, is what, and we can work back down So we see something like that. And that's relatively y equals x plus 1. And they say, what is the difference, or how do I go from y equals x? Well, y equals x has the origin as a y-intercept, and it's going to be parallel to it. Okay? And so what we're saying is that there is a shift up 2. Okay? In fact, their answer is that this is a vertical shift of 2 units up from y equals x. So this line right here represents y equals x. So our answer is shift 2 units up, because the only difference is the y-intercept has been moved up 2 places. Okay, let's come back to our question right here. All right, question number 8. Write an equation in slope-intercept form for the line perpendicular to y equals negative 8x minus 1 that passes through this point. Well, if it's perpendicular, that means I'm going to take this negative 8 and I'm going to make the reciprocal opposite. So I should get a slope of 1/8. 1/8 is perpendicular. And I'm going to use 2, negative 1, which means what I want to use is I'm going to use y minus y1. So that's y minus negative 1 equals 1/8 times x minus 2. All right, this becomes plus y plus 1 equals 1/8 x. And 1/8 times negative 2 becomes negative 2/8, which is negative 1/4 minus 1/4. And then we still need to move this one across. So I get y equals 1/8 x. And whenever we're subtracting 1, what we're really subtracting is 4 over 4. So negative 1 minus 4 is negative 5 over 4. Negative 5/4. We'll check our answer key here. Y equals 1/8 x minus 5/4. That's our work and our answer. Okay. Number 9, find the value of sine, cosine, and tangent for functions where a is 80, b is 84, c is 116. Of course, they don't show me the whole picture here, which is a little frustrating. So let's go ahead and fill this in. We've got theta here. A is 80. B, let's see. They don't really fill in the rest of it to tell me where all of this is. But if they tell me that A is down here, then angle A is up here. Okay, let's see. I don't know if even my picture gives me a better one or not. It does not. Give me a second. You would think that they would complete the picture, but they do not. Let's see. Well, I would follow our Pythagorean theorem. So I'm going to place 84 right here, where C, obviously. Okay, so I see what they're saying is that because in trig functions we're always working with the right triangle, our longest side has to be our hypotenuse, so we have this. So if we're basing this as my theta, sine is opposite over hypotenuse. So opposite of theta is 84, hypotenuse is 116. Okay, and we would reduce that down. We would reduce that down to 21 over 29. Okay, so that's what I should get for sine. Cosine is adjacent over hypotenuse. So what's adjacent to theta? Should be 80. Okay, adjacent means it shares a vertex, but it's not the hypotenuse, over 116. And as I reduce that, I get 20 over 29. And then finally, we have tangent of theta, which is opposite over adjacent. Opposite is the side that doesn't share a vertex, so that's 84 over adjacent. We already saw that is 80. And if it helps you to write, based upon this, opposite, hypotenuse, and adjacent, to kind of get those letters out, okay, this will simplify to 21 over 20. So our answers here are right there, and that's what you want. Okay, so even though they didn't give us all the information, just knowing that 116 has to be C because it's got to be the longest side of that right triangle. And they already tell me where A is, so B has to go what's left. Okay, we have enough information. Okay, let's come back up to number 10. Binomial expansion. All right, this one's a lot easier than what it looks, especially because they say it's to the 13th. It looks very, very difficult. All we need is one sentence here that tells me that I understand that there is one more term than exponents. All right, so I know that there will be 14 terms because there are 13 exponents. Okay, it is to the 13th, so there are 14 terms. That's the sentence you need to know and understand and be able to write on your test if you see a question like that. Okay, number 11. F of x equals 2x minus 4 using a dashed line. Then find the equation of its inverse function, g of x. Graph g of x using a solid line. Well, we find the inverse. First, we're going to write y equals 2x minus 4. And in order to find the inverse, the first thing I do is switch the location of the x and the y. So x equals 2y minus 4. After that, we solve for y. So I'm going to add 4 to the other side. So I get x plus 4 equals 2y. Then I divide by 2. So I get y equals 1/2 x plus 2. Y equals 1/2 x plus 2. All right, so if we have y equals 1/2 x plus 2 and they want us to graph that, using a solid line, y equals 1/2 x plus 2. Well, plus 2 is here. 1/2 x means I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. I could go down 1, back 2, down 1, back 2. And using, I don't know what they said. Yeah, we wanted to use a solid line. If we wanted our dash line for our other one, it came down to 1, 2, 3, 4. And had a slope of 4. So we saw something like, or let's see, it had a slope of 2. So we saw it kind of go up like that. Okay, so if need be, granted they'll probably give you a list of choices, but what you need to be able to do is you need to be able to draw this workout right here where you're switching the x and the y and solving for y. Okay. 12, what is the probability of tossing a coin 5 times and getting exactly 2 tails? If we're tossing a coin 5 times, we have 5 attempts. We need exactly 2 tails. Our success is based on a probability of 1/2 because we can flip a coin and we have 2 possibilities. We want to get exactly 2 tails, so we're going to put that 2 there. And we have a probability of 50-50 on failure, but we need exactly 3 failures. So that is going to be the equation I'm going to write. I'm going to pull out my calculator to get that answer. Okay, you might be a little different on a newer calculator, but essentially I'm going to get 5 math probability NCR 2 times 0.5, which is 1/2, to the second, times 0.5 to the third. And I get 0.3125. I hit math fraction, and I get 5/16. 5/16 is the correct answer. Okay, I've got a 5 in 16 chance if I flip a coin 5 times of getting exactly 2 tails. Okay, that's all the work you need to show. If you can show me that equation and that answer, you're all good. Okay, 13. Given the objective function, c equals 20x plus 70y in the graph, and vertices shown, find the maximum value. All you have to do here is plug these numbers in for x and y and show what gives you the biggest number. So here we do 20 times 2 plus 70 times 4. Okay, 20 times 0 plus 70 times 5. 20 times 4 plus 70 times 0. Okay? And our answers that we get out of this, we got 20 times 2 plus 70 times 4 comes out to 320. 20 times 0 is 0. 70 times 5 is 350. Okay? And 20 times 4 is 80. Okay? So we should get 0, 5, I believe, is our answer to this. Let's see if I'm looking. Let me find this. On question number 13. Find the maximum value for C. Given the objective function. Okay, this one plays off as kind of a trick question because what I did is I actually circled the wrong thing here. If you'll pay close attention, all right, let's plot the points that they give. They give you 2, 4, which is right there. They give you 0, 5, which is right here. Okay, let's see, did I mess up? Oh, we got 4, 0. The answer that they're coming up with is 0 correct. And I'm trying to figure out why 0, 5. How you could get a none correct whenever they give you 3 possibilities. The best I can figure on this question is that that it's obviously it is a multiple choice question, and so the answer should be 0, 5. Okay, find the maximum value should be 350, and my guess is that as I've done this, I've removed the multiple choice options, that if you were to look at the multiple choice options, you're not going to find a 350, which is what you get with 0 and 5 being used, which should be the answer, which is why, at least in the answer key that I have, it's coming across as none correct, although the answer should be 0, 5. Sometimes we get into some funky stuff where when you take a multiple choice question and make it non-multiple choice, you get some funny possibilities. All right, question number 15. We're halfway there, I think. F of x equals x cubed, g of x equals 8x plus 2. We want to find g of f of 2, which means what we're going to do is we're going to make g our main function. So we're going to start off with 8, and instead of where we see x here, we're going to plug in our f of x. So we're going to plug in that x cubed, but the reason I leave an empty space there is because we're doing g of f of 2. So actually inside of function f, where I have x, I'm going to plug in 2. Okay, so I'm going to close all that up and finish out g of x, which has a plus 2. All right, so what I have here is I have to do order of operations. So 2 cubed is 8. I get 8 times 8 plus 2. 8 times 8 is 64, plus 2 is 66. 66 is our answer on that question. G of f of 2 equals 66. Okay, that's what we call our Russian nesting doll question. 16, find the probability of drawing a green marble from a marble bag. The probability is 20%. What are the odds in favor of drawing a green marble? We have to understand the difference between probability and odds. Probability is the number of desired over the number of total. Odds is the number of desired over the number of undesired. So we actually need to do something with this 20%. We need to take 20% and turn it into a decimal, and from a decimal to a fraction. 20% is 0.2, which is 2/10, which simplifies to 1/5. All right, and because that's the probability, what we're saying is that this is my desired, this is my total. Okay, so if I want to switch this to odds, what we're saying is that there is 1 desired, which means if there's a total of 5 and only 1 is desired, that means 4 have to be undesired. So the odds are 1 to 4, and they're going to represent that like this, 1 to 4. Okay, 1 to 4. Okay, 18. We want to write this expression in a radical form and then simplify, round our answer to the nearest whole number. Okay, so we're going to take 16, we're going to put it inside a radical, and that means that 5 is on the inside, it's being divided by 2 here, okay? 16 to the 5th, okay, divided by 2. Let me flip over. Pause here for a second. It looks like I actually skipped a question, but we'll come back to question number 17 here in a little bit. All right, and for lack of a faster way to do this, I do want you to show this because it did say write it in radical form. So this is our radical form, but from here, the rest of this is just done in our calculator. So we're going to hit square root of 16 to the 5th and close that up, and we're going to see that our answer is 1,024. Now, they will take this. If you want to write it like this, you can write it like this as well. So either of those ways of writing it is acceptable. You're probably going to see this on your test, right? If we're looking at multiple choice possibilities, that will be how they want it to look. Okay, let's scoot up to 17. Okay, find the measure of the reference angle for negative 151 degrees. So let's draw our coordinate plane. Our initial side is this. Okay, it's negative degrees, which means we're going to go clockwise. Okay, this is 90 degrees, or at least negative 90 degrees. This is negative 180 degrees, which means as we come across, we're going past, and we're going to wind up somewhere over here. Okay, until we stop there. We will have gone negative 151 degrees in this direction, and our reference angle is always positive, and it is the angle between our terminal side and the closest x-axis. So what we want to do is we want to find out what is the difference or what is left over from 151 and 180. So 180 minus 151 should be 29 degrees. So 29 degrees is our answer. That is referring to this right here. That is 29 degrees. 29. All right, now let's move down to number 19. Number 19, divide 1 divided by y minus 6 over 6y. Okay, so let's do 1 divided by y, but let's multiply by the reciprocal, 6y over y minus 6. Okay, well, across the top, we know we're going to get 6y, and on the bottom, we're going to distribute the y, so we're going to get y squared minus 6y. Okay, and notice that we have all of these. We have a y here, we have 2 y's here, and a y here, which means we can factor out a y, and we are going to be left with 6 over y minus 6. 6 over y minus 6 is our final answer. Okay, that is reduced and simplified. Okay, number 20. Identify each graph as being a nonlinear function, linear function, or not a function. Okay, well, our first graph, and they're all kind of scattered here, so I don't know how well I can tell you what the answer is. I'll do my best. Okay, graph A, that should be what we understand is this guy right here. It is a function, it passes the vertical line test, but obviously as it curves, it's not linear. Okay, so we would call this a non-linear function. A non-linear function. Okay, coming down to our next one, okay, is graph B. Okay, we would say that that is a linear function. It passes the vertical line test, and it is a line. So it is a linear function. Okay, so we've got that. Let's see if we can, in graph C, because it's a vertical line, It does not pass the vertical line test, therefore it is not a function. We don't care that it is linear. It is not a function. Okay, that was question number 20, so we're going to slide over here to the right for question 21. It says graph the linear equation. To go about doing this, the first thing we're going to do is we're going to move it over to y-intercept form. So we're going to add 3x to both sides. So we have 2y equals 3x minus 6. We will divide by 2. Okay, so we get y equals 3 halves x minus 3. Okay, then we can go over. We'll go over to our graph. So we see something. It's going to be pretty rough. Let's see. We had y equals y equals 3 half x minus 3. So negative 1, negative 2, negative 3. And we're going to go up 3, 1, 2, 3 over 2, up 3, 1, 2, 3 over 2, so that we see something like that. And you can make more out of that if you wanted to. Okay, but that's just a start to it. Okay, based upon our equation, let's get back to our work. Y equals 3 half x minus 3. We need that work, and we need to pick the right graph. More important is being able to get the right equation. Okay, question number 22, find the zeros. So we want to factor this if we can. Let's see if we can. I'm going to get x and x. We got minus plus, so I have to have minus minus. And looking at things that multiply to be 5 but add up to negative 6, that should be 5 and 1. So my answer should be x equals 5 and 1. X equals 5 and 1 because x minus 5 equals 0. You add the 5. X minus 1 equals 0. Add the 1. X equals 5 and 1, or 1 and 5. Okay. Question number 23. All right, now this says use polynomial long division, but I will allow you to use synthetic division here. And in synthetic division, we can use synthetic division here, we can't always, but I would have 1, negative 6. Everything seems to be in order. I have enough of everything. I'm going to divide by 3 because x minus 3 equals 0. Add 3 to the other side. We'll bring our 1 down. 3 times 1 is 3. I'll put that there. We'll add. Negative 1 plus 3 is 2. 3 times 2 is 6. We add those. We get a 0 remainder. Because this was x squared, this is x. Okay. X plus 2. Okay, we get x plus 2. And make sure that that's the final answer. X plus 2 is my final answer. Okay, if you have questions, by all means ask. I'll have this ready, hopefully in well then enough time for you to ask questions before review day. All right, find the values of the 6 trigonometric functions. Our 6 trigonometric functions are sine, cosine, tangent. Then we have our reciprocal functions, which are cosecant, secant, and tangent. And I think these will stay simple enough. We do have something that we need to do before we can go very far, and that's that first we need to know what our hypotenuse is. We find the hypotenuse by setting up the Pythagorean theorem. 10 squared plus 24 squared equals c squared. We know this is 100. I'll have to look up 24 squared is 576. Okay, we got 676, which we're going to square root. Okay, square root of 676 is 26. So we know this guy right here, our hypotenuse is 26. All right, now we can go through and start finding our opposite over hypotenuse. Now this is my angle, so this is opposite, this is adjacent, this is hypotenuse. So sine is opposite over hypotenuse, so that's going to be 10 over 26, which I can tell will reduce. Okay, that should be 5/13. 5/13. Okay. Let's see, with cosine, we're doing 24 over 10, which should reduce. Okay. We can divide both those by 2. We're going to get 12 fifths. Let's see. Where are we at here? Cosine? Oh, I'm sorry. I already messed up. Okay. Over hypotenuse 26. Okay. So as we split that down, we get 12/13. Okay, so my cosine is 12/13. Tangent from there, opposite over adjacent, is 10 over 24. Divide both by 2, we're going to get 5/12. And then for our cosecant, secant, and tangent, all I have to do is take the answers from sine, cosine, and tangent and find the reciprocal. So just flip them. So I got 13/5, I have 13/12, and I have 12/5. Okay, because I reduced the first 3 trig functions, I don't have to reduce these any further. They're already as reduced as they're going to get. Okay, those are my 6 trig functions. If you struggle with that or what to do with that, that's lesson 46. Okay, lesson 46. Let's shoot down to number 25. Use Pascal's triangle to expand. Okay, so this is a longer question, but we'll go ahead and work it out. The first thing we want to start off with is Pascal's triangle. So with our 0 term, we get 1. First term is 1, our first exponent is 1, 1. Second, because this goes 0, 1, 2, and we need 3, 4. Okay, so we get 1, 2, 1. So we get our palindrome 1, 3, 3, 1, and 1, 4, 6, 4, 1. So this 1, 4, 6, 4, 1, these are my coefficients to this. Okay, so now the rest of this, we're going to use our 7x minus 8. So we're going to take, first, we're going to get 1 times 7x to the 4th. Okay, we start with our largest exponent. In this case, it's 4, because that's 4, times our b, which is negative 8 to the 0, plus, and now we go to our next exponent, or our next coefficient, which is 4 times 7x to the 3rd, negative 8 to the 1st, plus, go on to our next coefficient, 6 times 7x to the 2nd, negative 8 to the 2nd. You notice as one decreases, the other one increases by 1. Okay, until we run out, and then 4, okay, that 4 right there, 7x to the 1st times negative 8 to the 3rd, plus 1 times 7x to the 0, negative 8 to the 4th. And then we take our calculators and we solve these different portions. All right, so let's run our calculator, and from left to right here, try to figure this out. We've got 1 time, we know that negative 8 to the 0 is just 1, so that's not really going to change anything. Neither is the 1 out front, but what we do need is 7 to the 4th. Okay, that's 2, 4, 0, 1, x to the 4th. Okay, so we've got that one. That one's all done. All right, let's clear that up. Now we have 4 times 7 to the 3rd times negative 8 to the 1st. You don't have to put to the 1st up there because it won't change it. But that gives me a rather large number here, and it's negative 10976x cubed. Okay. All right, we're going to move our graphing calculator over to this side. Then we want to do 6 times 7 squared times negative 8 squared. Okay, so we get positive plus 18816x squared. Okay, let's clear out. Let's go on to our next one, which is 4 times 7 times negative 8 cubed. Okay, that gives me a negative 1, 4, 3, 3, 6 x. And finally, we have 1 times 7 to the 0. Well, 7 to the 0 is 1, so it's really 1 times negative 8 to the 4th. So we only really need to do negative 8 to the 4th to get our last number, which is 4,096 plus 4,096. As I check my answer key here, we've got everything right. What you see in that red line is our answer there, and that is the work. Okay. Let's goes kind of right there. All right. All right, let's come down to 26. And if you want to go back and watch a lesson on how to do that Pascal's triangle, you should be able to find it from lesson 49 using the binomial theorem. I don't know if there's a video on that or not, but there's certainly videos out there that you can look at. Now we want f of x equals x to the 5th. G of x is negative 6 plus 4x. Find g of f of x. We've done a problem like this so far already. We're starting with g. So I've got negative 6 plus 4. I want to leave a parentheses to plug f of x into. And because we're leaving it in terms of x, I'm just going to leave it like this. So just real simply, that's negative 6 plus 4x to the 5th. I would rewrite that as 4x to the 5th minus 6. But either way, in fact, actually, they leave their answer exactly like that. So that will work right there for 26. Okay, pretty simple. 27, this is another linear programming question. Hopefully this one goes better than the other. The first thing I'm going to do here, because they're looking for the minimum, the feasible regions are these coordinates. So let's go ahead and make a list of coordinates. U is at 0, 1. R is at 1, 4. S is at 4, 1. And T is at 2, 0. So as we look at this again, we're going to take our function, which is 3x minus 2y, and we're going to plug these things in. So 3 times 0 minus 2 times 1. We'll find an answer there. 3 times 1 minus 2 times 4. Okay, again, we're looking for the minimum. So actually, kind of counterintuitive. We usually look for the largest. Here we're looking for the smallest. And it's not always the thing that looks like it does. Negative numbers, no matter how large, the larger they get, the smaller they are. Okay, so 3 times 0 is 0, minus 2 times 1 is really negative 2. 3 times 1 is 3, minus 2 times 4. Well, that's really 3 minus 8, which is negative 5. 3 times 4 is 12, minus 2 times 1. So that's really 12 minus 2, which is positive 10. And 3 times 2 is 6, minus 2 times 0, which is 0. So I really just get 6 there. So 1, 4 comes down as my smallest number, or the minimum, what's going to give me my minimum value for my feasible region. So 1, 4 is our answer there. All right, 28. 28's a tricky one. Hopefully I can remember exactly how to do this. In a recent survey of 25 voters, 17 favor a new city regulation, 8 oppose it. What's the probability that in a random sample of 6 respondents from this survey, exactly 2 favor the proposed regulation and 4 oppose it? Express your answer as a decimal rounded to the nearest 100. This uses combinations, and because we're looking for number desired over number total, we're going to break up the original numbers with the numbers that we're looking for, and then put that over the number that we started with, again, the number total that we're looking for. Let's see, so we had 17 in favor, but we only want 2, let's see, in a recent survey, 17 favor, but we only want 2 to favor it. And out of those, what's the probability of a random sample of 6? Let's see. We had 8 oppose it. So out of that total of 8, we want 4 to oppose it, and our total was 25, but we're only using 6. So hopefully I've got this set up correctly. We're going to use our graphing calculator here. And we need to start off with by putting everything on the top row in parentheses. So we got 17 math. We're going to use our combination. Okay, 2. Let's see. Hopefully this works. We'll see. 8 math probability NCR 4 divided by 25 math NCR 6. It's been a while since I've done this, and yes, we did get the right answer. We wanted an answer of 0.05. Okay, 0.05 is our answer on that, and that's what we need to set up. Okay, if you have questions about that, by all means, email me or ask. But that question comes out of lesson 55, which I'm sure there's a video on. Okay, those videos are always up, so go back and watch them. 29, cosine of 135. We want to find that. So the first thing we're going to do is we're going to write this guy out. Let's clear that up. Cosine, so we're starting at our initial side. Notice that it's positive, so I'm going to be going counterclockwise. This is 90 degrees. This is 180 degrees. So as I go past 90, what I'm finding out is that I'm somewhere between 90 and 180. From here to here is 135 degrees. Okay, I want to know what my reference angle is. Okay, because I want to complete this triangle. And whenever I take 180 minus 135, I should get 45 degrees, which means this is 45 degrees. And in my special right triangle, that means I'm going to get 1 and -1 and radical 2. And the reason this is -1 down here is only because we're left of the y-axis. And if I want cosine, that means that I'm doing adjacent over hypotenuse. So that's -1 over radical 2. I can't leave it like that. I have to multiply by my denominator. So I get negative radical 2 over 2. And let's check the answer here. That's exactly what they get. Negative radical 2 over 2. That's right there. So don't forget where you are. Okay, that is from lesson 56. And finally, last question on here, question 30, at least I think it's the last one. Simplify, assume that all variables are positive. All right, so we're looking for the 5th root of 243 z to the 10th. Well, the z to the 10th we can take care of real quickly because with that variable in the exponent, all I have to do is divide the exponent by the root. So I should be able to get z squared on the outside because 10 divided by 5 is 2. The next thing is I need to break 243 down and see if there's any sets of 5 that come out of it. Okay, let's take 243 divided by 3. Okay, that gives me 81. Well, I know we can divide that by 3 because we can divide it by 9. That's 27. Well, we know we can divide that by 3 and get 9. And we know we can divide that by 3 and get 3. So if I count these, I got 1, 2, 3, 4, 5. So we can actually pull 1 3 out of that. So that 3 comes to the outside, and I'm left with 3z squared. That's out of lesson 59 using fractional exponents. I hope this has been helpful. I'll be sending you the review document with the answer key so that you can look everything over, and that'll help you out. All right, good luck.